The wood pellet industry in the UK has grown massively over the last 10 years, and we now have a robust supply chain and an excellent support network. We need to work together with the rest of the industry to make sure that the customers have a good experience. And the point of this video is just to talk a little bit about storage and handling solutions. And what we're just trying to identify is the things to do and the things not to do. And at the end of the day, if those are followed, then the experience of the customer will be a good one.
Wood pellets are a great quality biomass fuel, offering cost-effective low-carbon heating. But they need to be part of a good wood pellet boiler and fuel storage design. Doing wood pellets right is what this training film is all about. Wood pellets are convenient to use because they are dry, have a high energy density and flow along pipes and down fuel silo slopes. They are made from sustainable woodland residues manufactured to tough quality standards such as EN+, and delivered by specialised vehicles to your building or factory door.
One of the key things is to get the design right. I know it sounds obvious, but you see a lot of systems that are not well designed.
Nick Douch of Douch Biomass is an experienced modern wood heating installer. Nick and colleagues have been installing modern wood heating systems for over a decade. With nearly 70 projects under his belt, from domestic to large industrial, we showed him some examples of good and bad wood pellet silo design. What did he think of these designs?
So the access is quite tight, and there's a manhole there in the driveway. Often domestic standard manholes are not sufficiently robust. The access to the filling hoses for the pellet store is not good for a number of reasons. To make a good waterproof connection, you don't really want the hoses coming out through the building, coming up at an angle. They should really come down vertically.
I'm going to lift the grid out and lift my pipe down there.
There's also considerable fall hazard here. The driver's got to remove the gratings. It would have been better really if the hoses had been brought up through the gratings, and so they wouldn't need to be removed.
Just poke it in the hole so I can connect it when I get down the bottom.
Not all project designers think through vehicle access and proximity to the silo. Instances of poor access can force the delivery driver into using more than 30 metres of pipework or connections high up on walls. This leads to damaged pellets, delays, health and safety risks, and much higher costs for everyone.
Pellet stores themselves, obviously they need to be designed to the correct size to minimise the number of deliveries.
Storage silos come in all shapes and sizes. Tall commercial silos, metal fabricated and breathable bag systems, and bespoke brick and wooden systems to fit a particular space. As well as constructing silos to safely contain the weight of the fuel, a ground rule to all wood pellet projects is that bigger really is better.
I'd say the bigger store you can go for, the better. When you're taking a smaller quantity, you may have to take more deliveries over the year, and it is more expensive for that delivery as well. So the larger store that you can have, if you can put in a store that will last you for a year, it will be more cost effective for you and for us.
Small silos might save a bit of money up front, but with more deliveries and more time spent per tonne of pellet delivered, they cost everybody money. Opting for a 7-tonne rather than a 3-tonne silo can cut delivery costs by up to 2/3.
Right, here we've got a really nice big store in here. Just going to check, make sure the boiler's turned off.
Wood pellet is typically blown into a wood pellet store from the delivery vehicle, so it's important that the pellet is not blown hard against the back wall of the pellet store, because that will cause it to break up. You'll get issues with dust, and the quality of the fuel will be degraded.
Designing wood heating projects which allow delivery to take place close to the silo is a key step. But what about inside the silo itself? Understanding what happens here is important for designers, boiler installers and the pellet delivery industry. The design aim is to allow the smooth flow of pellets into the silo, a soft cushion impact inside, and ensuring the silo truly fills to capacity. Pipes with right-angle bends will cause pellet damage, and any hard surfaces or metal intrusions in the expected pellet flow will all cause further damage.
This is a wood pellet impact mat. It's normally located in the back of the pellet store, opposite the point where the pellets are blown in. The first thing the pellets hit as they come into the store will be this mat. Being soft and flexible, it absorbs the impact of the pellet.
Blasting pellets against a hard surface will obviously cause damage to the fuel. Placing the pellet mat just in front of a hard surface won't really protect the pellets either. Placing the mat too close to the pellet flow pipe will result in the pellets all piling up at the front half of the silo and none at the back. In many instances, hanging the pellet mat securely around 50 to 70 centimetres in front of the rear wall works well. For longer and bigger silos, multiple mats may be needed. Other problems include mixing up different sized pellet pipes, multiple sharp pipe bends, using unsecured pipes that can flap around in the middle of an office, and putting pipes blowing out pellets too near a ceiling. These will all cause pellet disintegration and poor combustion in the boiler.
It's important that every aspect is right, but one mustn't overlook the smaller points. For example, the slope of the pellet store, the angle needs to be correct.
While pellets flow nicely down a slope without help, that slope needs to be at least 45 degrees from the horizontal. For tall commercial silos, the angle of slope should be nearer 60 degrees from the horizontal. Shallow silo slopes will mean that pellets will lie around in pockets and need clearing at the annual service.
Obviously ventilation is important. You don't want to build up carbon monoxide. The other thing that needs to be considered is personnel access into the store for routine maintenance, and also you need visual access in the form of windows or some such, so you can actually see how much pellet you've got in there at any one time.
Detailed advice on all these design issues is available free online. So let's sum up the key design issues of doing wood pellets right. Ensure good pellet delivery vehicle access and close proximity to the silo. Minimise pellet delivery pipe lengths and bends. A bigger silo is usually always better to reduce deliveries and costs. Make sure you design in soft pellet delivery, correct pellet mat positioning, direct pipe routes and soft sweep bends. Remember that the design detail matters. This includes everything from proper access into silos for maintenance and repairs and ensuring carbon monoxide venting and protection. Use the detailed UK Pellet Council design guide, which is free online, and get experienced advice early.
The industry has worked hard to achieve the M+ standard, and what we don't want is your pellets turning into dust because you've got the design wrong.
The objective is to get good quality pellets like this into the store and not dust.
The golden rule of modern wood heating is that the system works and the customer's always warm.
We've got good quality pellets now, we've got a good supply chain. The challenge now is that everybody in the industry needs to work together so that we have a good, robust storage and handling solutions, and in that way the consumers are going to have a very good experience.
That's it, job done.